Good morning, friends. Today we will discuss about the Hund's rule of maximum multiplicity. Hund's rule of maximum. Hund's rule of maximum multiplicity. Here in this case, we will discuss about the filling of electrons in the orbital belonging to the same subset, that is the orbital of equal energy, or it means that equal energy, it means that the degenerate orbitals, that orbitals are degenerate orbitals, and the statement of the Hund's rule of maximum multiplicity is the pairing of electrons in the orbital belonging to the same subset does not occur unless each orbital belonging to that subset has got one electron each. It means that is firstly the one electron is added in each orbitals. After that, then next coming electron is added in the next orbitals. Like this is the statement of the Hund's rule of maximum multiplicity. For example, here in this case, suppose the example that is 1s orbital. 1s orbital. The s subset, here this is the s subset. In the s subset, how many electrons are present? Maximum 2 electrons are present. Firstly, these are the 1, this is the 1s2. Then 1s2, 2s1. Here in this case, in the s orbital, 1s2, 2 electrons are present. Then the coming electron is added in this orbit. That is, on the head, here 2 electrons are present. In the 2s1 orbital, 1 electron is present. Another example, 1s2, 2s2. Here in the subset, 2 electrons are present. But why in case of p orbitals, 1s2, 2s2, then 2p1? What happens in case of s orbital? 2 electrons are present. That is, these electrons are present in the anti-clockwise directions, and this is the 1 electron is present in the 2p orbitals. Then another example, this is the example of helium, that is only 2 electrons are present. This is the lithium, this is the beryllium, this is the boron. Atomic number of boron is 5, beryllium atomic number is 4. Then the carbon atomic number is 6, that is 1s2, 2s2, and then 2p2. It means that these electrons are present in the 2 electrons are present in the s subset, these 2 electrons are present in the s subset. But these 2 electrons in the p subset, no 2 electrons are added at the same time in the same orbit. That is, one electron is added in the p subset. That is, one electron is added in the one orbit, another electron is added in the another orbit. Like this, the firstly, the one electron is added. Another example, nitrogen atomic number is 7. Electronic configuration is 1s2, 2s2, and then 2p3. Here the orbitals are firstly 2 electrons are present in the S subset, another 2 electrons, and here in this case in the P subset 3 unpaired electrons are present. 3 electrons are present, but these 3 electrons are not present in the same orbit or in two orbits. Firstly, the one electron is added separately in the separate orbitals. Here in this case, this is one electron, another electron added in the another orbit, and then remaining electrons is added in this orbits. Like this, the filling of electrons in the orbitals. Firstly, the one electron is added in the each subset, each orbitals by this Hund's rule of maximum multiplicity. Another example, oxygen. Oxygen atomic number is 8. Electronic configuration is 1s2, 2s2, 2p, 2p4. Here in this case, these are the 2 electrons in the subset S subset, 2s2, these 2 electrons. Then in the 2p orbital, that is p subset, it contains the 4 electrons, and these 4 electrons, how the 4 electrons are added in the p subset. Firstly, the one electron is added in each orbitals. One electron is added in the each orbitals. Then remaining electron is added in the by anti-clockwise direction here in this first subset, that is 2px. This is the 2px orbital, this is the 2py, and this is the 2pz orbital. Firstly, the electrons are added in the subset p subset. If one electron is present, then added in the first subset, that is 2px orbital. If the 2 electrons are present in the p subset, then 2px 2py orbitals. If the 3 electrons are present in the p subset, then 2px 2py 2pz. If the another electron is present, that is the 4 electrons are present in the p subset, then firstly the one electron is added, then another remaining electrons are added in the anti-clockwise directions. That is pairing takes place in the 2px orbital. Here one paired electrons and 2 unpaired electrons are present. Like this, we continuously added in the subset. So this is the Hund's rule of maximum multiplicity. Hund's rule only states that is the filling of electrons in the orbitals. How the filling of electrons added in the orbital, that is one electron is added in the orbitals. After that, the pairing of electrons takes place. So this is the statement of the Hund's rule of maximum multiplicity. Very simple. Then another example, that is chlorine. Atomic number is 9. Electronic configuration 1s2, 2s2, 2p, then 2p5. Here 2 electrons are present in the 2s2 orbital, that is 1s2 orbital. Here 2 electrons are present, and then in the 2p orbital, that is one electron is added. Firstly, 5 electrons are present in the p subset. Then remaining 2 electrons are here, that is added in the anti-clockwise directions. So this is the 5 electrons are present in the 2p subset. Then another example, that is neon. Atomic number is 10. Electron configuration is 1s2, 2s2, 2p6. This is the S subset completely paired. 1s subset is completely paired, 2s subset is completely paired. Then the 2p subset is firstly one electron is added, 3 electrons. Here in the p subset, how many electrons are present? 6 electrons are present. then another 3 electrons are added by anticlockwise directions, and this is the 2p subset is the completely fulfilled orbital. That is, neon is a inert gaseous. Inert gaseous, it means that the outermost shell is completely fulfilled. 1s2 2p6, 1s2 2p6. That is, this inert gas, that is the neon is the inert gaseous, neither they gain the electron nor they donate the electron. So this is the completely fulfilled subset of P subset, and this is Hund's rule of maximum multiplicity.